Tom, diameter signaling is a hot topic today, and we're here at the 2013 CCA meeting. And if you don't mind, could you take us back in time and let's review the history and evolution of telecommunications signaling?
Sure. We started out with SS7 back in the mid-'80s. It was our first step at out-of-band kind of signaling. And basically, the evolution of signaling as we moved to next-generation networks, the ISAP portion of SS7 was replaced by SIP, and the TCAP portion of SS7 was replaced by diameter. Today, we're going through some of the same issues that we went through in the early stages of deployment with SS7, incompatibility of the diameter protocol stack between different vendors all over the world. And the other thing that we're looking at today and people are talking about is traffic, the amount of traffic on the diameter network, and the correct architecture for the diameter network. Whether it should be a more centralized kind of network for diameter routing, or whether it should be a mesh kind of network without centralized routers in the network. A lot of the lessons we learned in SS7 in the days are transportable to what we're doing today in LTE EPC diameter networks. The ability to put in centralized routing and to control all of the routing within the network is key to the success of the network. Also, the ability to put in diameter edge routers where all of the interconnection exists in the network and handle those edge connections on a per instance basis so that you can allow what you want into your network for security purposes, disallow what you don't want in, and shape the traffic and steer roaming within those interconnected networks. That is key to the success of the diameter protocol within LTE EPC diameter environment.
What happens if a carrier doesn't get ahead of the LTE session curve and they don't start implementing diameter routing, diameter signaling solutions?
It is always easier, and we ran across the same thing in SS7. Some people along the line said, oh, we don't need to put in STPs. But then when you put those STPs in, you have to rehome all the links, rehome all the routing, redo all the routing. Although diameter runs on IP, the transport protocol for diameter is Stream Control Transmission Protocol, which is a connection-oriented methodology. Although it's logical connections, it still has a lot of similarities between the old low-speed wired connections and all that. So if you put in diameter routers and you plan for that network from the beginning, you don't have to go back to all the switches, retranslate all the switches, and do all the data fill and change that. Because anytime you do that, you are in jeopardy of taking down that network and creating major problems within the network. So that planning should be done up front such that you can put the routers in. In fact, some people say they put the routers in first and then put the surrounding EPC core around them and do all the translations for that.
So where does PT play in that equation, and tell us about some of the successes you're having and why you're having those successes?
Okay. PT's specialty in telecommunications is routing. SS7 routing, we have a full portfolio of SS7 routing, STPs, advanced routing and screening over and above the normal things that you do in SS7 routing. We have an internal routing engine that all our products are based on. So we reutilize that same engine for diameter routing. The only thing that changes is the protocol definition. That allows us to take all the experience we've learned in SS7, translate that into the LTE EPC diameter space, and move forward. It also allows us to interwork between diameter and SS7 and provide a seamless capability to allow service providers to migrate from one to the other without all the disruption.
Now, telecom software seems to be a buzzword these days. It's been around for a long time, but you hear it increasingly as hardware guys are now calling themselves software guys. What is PT? Do you think of yourself as a software company, a hardware company? What's underneath the hood?
We started out our company as an embedded hardware company years ago, and from that we have migrated, and granted we still make some of our own specialized hardware, but in today's environment we are specifically a software environment company. That's what we focus on, whether it be SS7 routing, diameter routing, any of the protocols.
Can you talk about some of the connection points whether it's your solution or somebody else's diameter signaling solution, what are the touch points into a carrier network, and how are those implemented?
Okay, you've got a whole set of interfaces, whether it be from a P gateway, an S gateway, an HSS, an MME. Not only that, you can also, with the EPC diameter network, you can connect to, and the whole architecture and the definition of it is so that you can connect to other networks, whether they be CDMA networks, whether they be WiMAX networks, whether they be CDMA networks. So if you look at the whole constraint of routing, you have to be able to mitigate those different points from all that different equipment. The other thing is, we're going through today in the diameter space a lot of inconsistencies in the implementation of the diameter protocol. So it's extremely important for diameter routing engines to be able to look at any of the attribute value pairs within diameter, be able to manipulate those, be able to route on any of those pairs, and be able to mitigate the inconsistencies within those diameter protocols. Because bottom line, a network service provider can test all of the environment within their network, and they know that environment. What they don't know and what they can't control is what equipment is located in the interconnected networks, whether they be 3G, whether they be LTE, PC. So the ability to look at those and mitigate the protocol inconsistencies is key in the network.